We're live, woohoo! And this is multiplying and dividing radicals. This particular one is from section 8.4, and I brought our friend Square Bear. And just a little note, if you haven't already watched the video I made about bear math, you might want to watch it because I do square roots in a slightly different way. A lot of a different way because there are bears involved in my square roots. So you might want to go back and watch it if you haven't already seen it recently, because it's a little bit weird, but has been pretty successful for folks. So I'm going to keep using it. This first page is a lot of theory, and I wanted to type it up so you didn't have to try to read my handwriting. So let's go through this and see what we can see. So for this particular section, we're multiplying and dividing radicals, but these are all going to be square roots as opposed to cube roots or fourth roots or any of the other bigger, larger indices or indexes. So as long as they're both square roots, you can easily multiply two radicals. And believe it or not, you've already been doing it. You're soaking in it as we speak. If I have, say, and here I'm going to use the convention of saying the square root, but I always mean the principal square root or the positive square root. If I mean the negative square root, I will specify. So I'm going to use the convention of saying the square root. Occasionally I'll flip back to radical, which is considered by some a more proper way to say it, but less specific. We're talking in this section about square roots, so I'm going to say square root. So the square root of 8, or principal square root of 8, times the square root of 2, or the principal square root of 2, is equal to, and then you just multiply the 8 times the 2, and you get 16. And then an amazing thing happens, because we do know the square root of 16, or the principal square root of 16. That's 4, so we can actually simplify it. So in this case, multiplying these two radicals together was really helpful, because we could get a nice, beautiful whole number answer. Now, it's not always that satisfying. Sometimes when we multiply square roots, like if 7 is in the radicand and 5 is in the radicand, then we end up with the square root of 35, which is so close to the square root of 36, but not quite. So it's just slightly less than 6. This is a number. You could absolutely, and I'll remind you, in case you're a little rusty. Oops, let me get this out of the light. Oh, there's lights everywhere. Go into the light, Caroline. Okay, so if we're talking about radical 35 on my calculator, you do second and then the x squared key, which will give me a square root. It'll be different on different calculators. So radical 35 or square root of 35 is, you can see, almost 6, but not quite. So is it equal to a number? Absolutely. But it's an irrational number, and it's not a number I have memorized in any way. I just know it's less than 6. Okay, so going forward, you can also multiply. Remember, multiplication does not require numbers to be in the same format. You can smash any two numbers together with multiplication. So I can multiply a whole number times a radical, and it's a slightly unsatisfying result, though. 6 times radical 2 is just 6 radical 2. There's nothing fancy, nothing simplifies or reduces. It's just, you can do it. You can also go the other way. If you can smash two things together, then you can also pull them apart. So we can split radicals into two products, which sometimes we'll do because it's going to be nice to simplify. For example, if I have radical 200 or square root of 200, I can break this down into, right, the 200 right there. The 200 is just 100 times 2. And so I can split it up into radical 100 times radical 2. And the nice thing about that is that, let me underline this with blue. I know I've gone absolutely bonkers with colors today. Yay, colors! Radical 100 or square root of 100 is just 10. So I can simplify, and this is considered a more simplified form than this one. Now, it may be that you look at this one and you say, oh, I like this one better. That's fine. But this is considered more mathematically simplified. And as we're going to talk about in this section right here, unfortunately, what is possible becomes what is required. Oh, joy. Math loves doing that. Hey, let me show you something cool and fun, and now you always have to do it. Yep. If you can simplify, then you have to simplify. Radicals are very similar to fractions this way. In the same way that you have to reduce fractions, you also have to reduce, that's in quotes, it's not really called reducing, it's called simplifying, but you get the gist. You have to reduce radicals as well. And that's what we're going to talk about a lot in this section. So then there are a couple other rules. You cannot leave radicals in the denominator. It's not just style, it's good manners. Really, if you were going to meet with the Queen of England and you're like, hey, let's talk about radicals, you would never present her with a radical that has either a fraction inside of it or a radical in the denominator of a fraction. It's bad manners and it's awkward to work with and they're just kind of nasty. So that's another thing we're going to talk about in this section. How do you deal with that? Oh no, I have a radical in the denominator. What do I do? Do I call an exterminator? And the answer is no, you call Square Bear and Square Bear can come help. Okay. More theory. You might want to take a break, get a drink, because this gets a little dark in here and it gets a little thick. And what's going to happen is the way that we teach math in this country is you take algebra like 2 or 3 times. And every time we're going to talk about this, and every time hopefully gets a little clearer. So this might be the first time you've ever heard this, in which case, I understand it makes everybody feel a little dizzy at first, but I guarantee you that it just becomes merely annoying and not confusing and annoying, just annoying once you get some good practice with it. So trust in that. Okay. If I take the square root of x squared, let me make it big because you know how I love to make things big. Square root of x squared, does it equal x? So if we square something and square root it, shouldn't we go back down to x? That would be brilliant, right? But there's our wrinkle. If x starts out as a negative number, then x squared becomes negative 2, the quantity squared becomes 4. It has forgotten the negative is forgotten. That's the problem. That's also the benefit of squaring. When you square something, you don't have to deal with negative numbers. It's brilliant, but it also forgets that it used to be negative. So when you square it, you get up to 4, and then when you take the square root, it sees 4 and it says, oh, the square root of 4 is 2. And you'll notice these are not the same number. So you go from negative 2 up to 4, but then when you come back to a different place. So if I were to draw a picture of this, because I feel compelled to draw pictures this morning, if I were to draw a picture of this, if I start out at 2, and I square it, x squared, I get to 4. And then if I square root it, I come back to 2. Isn't that lovely? But if I start at negative 2 and I square it, I end up at 4, and then I come back to the wrong number when I square it. So it's not, it doesn't go around, it's not, we don't have Elton John singing It's the Circle of Life. We have, I don't know, Justin Bieber singing It's the Awkward Non-Circle of Death or something like that. Who knows? I know Justin Bieber was going to come up today. It just was going to happen. So there we go. I feel better. It's out of my system. But do you see how negative 2 goes to 4 and then it comes back to 2? It's not the beautiful circle of life. So what do we do? Well, to be honest, most of the time we just ignore that. Truth be told, we just ignore that. How do we do that? Well, if in the instructions you see that variables can represent all real values, we're going to need to deal with it. If the instructions say the variables only represent non-negative values, so you can't have, so in other words, the instructions say, nope, no -2s, then you've got Elton John, happy lion singing the circle of life, and you don't deal with this nasty thing. However, if, and I hid it in here, I love how I hid it in here, I'm realizing since that was really not very nice of me to do this. So, if I say, what does the square root of x squared equal? Well, if x is any value in the set of reals, so x can be positive or negative, then radical x squared is absolute value of x, because it gives you, if you start off with a negative, you'll end up with the positive version. So it'll end up with the positivized, the absolute value of the number. If x is greater than or equal to 0, then radical x squared equals x. And this will be seen in the instructions. So and I'm going to be honest, I was a math student for many years, probably more than I should have been, but I remember doing homework and you go blah, 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 blah when you read the instructions. This is a situation where you have to pay attention. So what you're looking for is if variables can represent all real values, then we're in this land. Try not to take you to Smeary Town. And if the instructions say variables only represent non-negative values or something similar, then we're in this land. Isn't that awesome? So sometimes there will be absolute values, sometimes there won't. It is a very formal part, it's a very theoretical and formal part of math. It isn't always useful. So you're going to see a lot of your homework is going to be in this land where you're just dealing with non-negatives or even possibly just positive numbers. Okay, so what about radical x cubed? Well, the great thing about odd exponents is if x is negative, then x cubed is also negative. And the thing is if you've got an odd exponent in a radical, then by definition, the numbers that you're plugging in, the values like x, they can't be negative. So as soon as it's an odd number, you don't have to worry about it. So no absolute values. And I know this is a lot. So what is the bottom line? The bottom line is, if someone's asking you to take the square root of x squared, ask them, reread, say, hey, are we dealing with this land or are we dealing with this land? Or you could simply ask your teacher, do you want us to use absolute values or not? Okay, so lots of theory. Congratulations, you made it through. Let's do some problems. Yay, we love problems. Okay, so let's simplify. Oh no. Notice I just said simplify. I didn't tell you where x is going to be. There's an x squared in there. It means we're going to deal with absolute value. Oh no. But you can totally do it. So again, I'm going to use my bare math version of this, which is going to require that I write this out, give myself lots of space, and I have to factor 18, and I get 9 times 2, and 9 is 3 times 3, so I've got 3 times 3 times 2, and then I'm going to write out my x's, and then my y. I gave myself way too much space, but that's okay. So remember square bears. So if I want to simplify, I want to get these guys out of the radical, which is our little cabin in the woods. I take pairs of identical numbers. Woohoo! Like 3 times 3. They go running. Ah, the square bear comes. Yum, yum, yum. Eats one of them. I know, if you haven't seen that video, this is a little weird, but okay. Each one, and then one makes it out. Thank goodness. The two's not going anywhere. It doesn't have any identical twins here with it. Here we go. X times X. X times X. They go running. The square bear comes. Yum, yum, yum. And then the Y cannot go anywhere. So the 2 and the Y are stuck inside. And then we have to think. The X. This was X squared. So there's no way to know whether X was a positive or a negative number. But we know that when X comes running out, the process of running through the forest, your minus sign is just going to fall right off. I know if you've ever been out, if you've been chased by a bear in the forest, you know the minus sign just falls and you don't go back to get it. Don't go back to get it. That's the crucial mistake many people make in number bear, square bear attacks. Don't run back to get your negative sign, but because of that, we don't know whether you lost it or not. So we're going to have to put the absolute value in. So we get 3 times the absolute value of X times the square root of 2Y. I know, it's not pretty, but it's true. Okay, let's do another one. Now, number 2, I get very excited. We're having a dance party. Even the bear, I know he looks scary, but he's having a dance party. Everyone's having a dance party. Yay, dancing, I'm flossing. I'm pretending I'm flossing. You can't really floss in 2 dimensions, but okay. So the reason we're all dancing is notice odd exponents. Odd exponents. Not the value. Woohoo! Okay, but it does mean, I wrote these out. They're quite extensive. So I'll remind you there are many ways to approach this problem. And in this case, bear math may not be your favorite way to do it. It is a way to do it, but it's going to take a long time. 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then Z, 3, Z, 6, Z, 9. Oh my goodness. So bear math can be very time consuming. And again, if you already have ideas about how to do this, you should do it differently. However, this is the best way for you. Let's do it. Okay, every 2 X's go running. Yum, 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 yum. 1 X comes out. 2 X's go running. Yum, yum, yum. 1 X comes out. 2 X's go running. Yum, yum. So out of 7 X's, there are 6 that can be paired up. So that gives us 3 that get out and 1 that stays in the cabin. So from there, you can kind of guess about the Y. I've got 11 Ys. There are going to be 10 of them that I can pair up. Let's check that. There's a Y. Yum, yum. There's a Y. Yum, yum. There's a Y. Yum, yum. There's some Ys. Yum, yum. There's some Ys. Yum, yum. We get 5 Ys that get out, 1 Y that's in. So with the Z, you could think if there are 9, then there are 8 of them that can pair up. And once they pair up, 4 will make it out. So you can start, you don't have to use bear math for the whole thing. Hopefully bear math will help you to start to see the pattern. And math is all about the pattern. That's literally what we're studying. We're saying, hey, I wonder if this happens the same way every time. And the answer is, yeah, generally speaking, it does. Okay, so let's see. I got 3 X's that got out, so it's X cubed because this is all multiplication. I've got 5 Ys that made it out and 4 Z's. And then a few that couldn't pair up, so they're just hanging out. We're going to save them later. And again, you don't have to do it this way, and hopefully you're starting to see the pattern, like 7 gets us 3 out and 1 left over. It's almost like you're dividing by 2. 7 divided by 2 is 3 with 1 left over. 11 divided by 2 is 5 with 1 left over. And 9 divided by 2 is 4 with 1 left over. Ah, it's almost as if there's a pattern here. Yay! Okay, so I'm going to stop here. In the next video, we will continue. I know, I said we were going to multiply and divide, and we're not multiplying and dividing yet. I realize this. Next video, I promise, it's all sitting right here. It's getting ready. Look at that. Oh, you can't see that. There you go. See? Little preview. I know, you're very excited. I know. I couldn't sleep thinking about this myself. So, woohoo! Congratulations on getting through yet another video of math. I hope you guys have a great day. I hope you have a great life. I hope you have a great universe. All the wonderful things and blessings on you. Woohoo. Oh, my goodness. We're getting deep today. Okay. Math on, guys. Math on. Woohoo!